So hello friends, in the last video we read about NaCl type structure of ionic crystal and CaCl type, NaCl type and CaCl type. So now we will go for ZnS type. CaCl type I will discuss it a bit again. So before going to ZnS type, please look after CaCl type again. In CaCl type, this is also an AB arrangement. This is also an AB type arrangement. A is Cl and B is CaCl. This is BCC type. Coordination number is 8:8. Then Cl is present at primitive unit cell, that is Z is equal to 1, and Cs plus is present at BCC, body centered cubic cell, that is also Z is equal to 1. So now I am just showing you the structure of it. If this is our unit cell, then from the middle just take something on the middle like this. Okay, suppose this is the middle part. From this corner, 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 this corner, this corner, and from this corner also. So this is it. From every corner it is attaching here. So that is the CaCl type. The middle one is the Cs plus and these all are the Cl minus. Okay. Now let's move to the ZnS type. This is also known as sphalerite type. In sphalerite type is also known as the ZnS type, also known as zinc blend. Is also known as a zinc blend type. Here the CCP type arrangement takes place. CCP type or FCC type, whatever you can say that. CCP type or FCC type. S2 minus forms a FCC, cubic Zn2 plus are surrounded by 4 S2 minus tetrahedrally. What was tetrahedral arrangement? Here one, here one, here one, and here one. So this is the tetrahedral arrangement, and it's saying that each Zn2 plus ions are surrounded by S2 minus, 4 S2 minus tetrahedrally. This is Zn2 plus. So the center one is Zn2 plus and S2 minus are the surrounding atoms. Surrounding atoms are S2 minus. Here Zn2 plus takes place present at half of the tetrahedral word, which is half into 8, which is 4. Coordination number of tetrahedral word is 8. So then in same way S2 minus has FCC arrangement, and FCC arrangement is equal to Z is equal to 4. So here also Zn4S4, so which is equal, simplified form is ZnS. Then next way. So by this 4 surrounding atoms, I hope you can guess that the coordination number will be 4:4. 4 coordination here in this ZnS type. Zn in tetrahedral void, okay, surrounded by s2 minus atoms. Then the next thing that comes over here is that its radius ratio. Its radius ratio is a bit complicated one. Still then, see here, r plus by r minus is equal to 0. Let me write here. It's 0.40. So 0.40 means, from that you can well guess that which type it will be. 0.40 means it's less than 0.414. So 0.225 to 0.414. So 0.225 to 0.414. The range is between 414. And this range, this 0.225 to 0.414, this range coordination number is 4. Okay, so this range coordination number is 4. Structural arrangement is tetrahedral. Okay, and type is ZnS type. Examples are CuCl, CuBr, then HgS, and all. So these are all the examples. Then we will see. We saw the ZnS type. We saw the AB type crystal of 3 arrangements. Now we will see the AB2 and A2B arrangement. The AB2 and A2B arrangement. In this AB2 or A2B arrangement, the first one is CaF2. The first one is CaF2. Here you can give the example of CaCl2 and BaCl2 and all those. How can you give? See, if we take A as Cl, then F2 will be B2. Okay. Here Ca2 plus ions are present on the CCP arrangement, and F minus ions are present in TV. So here it is 8 and here it is 4. But the question comes, but why but? So that's why but is because the ratio is 8:4, not 4:8. It is 8:4. But why? The question arises here. It is because coordination number of calcium ion is 8, and each calcium cation is surrounded by 8 fluoride ions, F minus, F minus, F minus, F minus. Here F minus, F minus, F minus, F minus. In this way, 1, 2, 3, 4, 5, 6, 7 and 8. So this is the arrangement. 8 atoms are surrounded of F minus on Ca2 plus. So here coordination number is, this is C number, okay. So coordination number is 8 of calcium ion, as it is surrounded by 8 F minus ions. So radius ratio is here R plus by R minus is equal to 0.73 approximately. So 0.73 means it has cubic arrangement. Yes, it has also. We have the proof that because it is of CCP type, CCP or FCC, face centered cubic cell or closed cubic packing. Okay, so that is why it has the coordination number 8:4. Then in the same way, what happens in A to B arrangement? Let us see. let us do here in A to B arrangement, just nothing to write systematically, else I would have taken another paper. Just few lines to explain you. In A to B arrangement, yeah, I forgot to say you one thing. This CaF2 type arrangement is known as the fluoride structure. And this A to B arrangement is known as antifluoride. From the word itself, now you would have understood that it will be just the opposite of it. Yes, you're right. It's just the opposite of it. The cations and anions are reversed. The cations and anions are reversed. There the coordination number was 8:4. Here coordination number is 4:8. There also CCP, here also CCP arrangement. CCP arrangement is common. But here, suppose let's take an example of Li2O. Okay, A to B structure, let's take an example of Li2O. Li plus has coordination number 4 and O2 minus has coordination number 8. And Li ions are present in the TV tetrahedral structure arrangement and O2 on the CCP type arrangement. So again, this is of 8. Tetrahedral one, na? So this is of 8 and this is of 4. Coordination number should come like 8:4, but it is 4:8 as lithium cation having 4 coordination number. And so in this way, antifluoride AB2 and A2B are reverse of each other. And now we have completed the structure of ionic crystal arrangements and all these. Now let's see a common thing, basic thing. On this crystal structure, effect of pressure. Okay, when you increase pressure, coordination number also increases. It means that NaCl type, okay, not NaCl. NaCl type becomes CaCl type. Not that NaCl becomes CaCl. This NaCl, that is 8:8 coordination numbers, becomes 6:6. Okay, I'm sorry, increases, no? So 6:6 becomes 8:8. In this way, in temperature, the reverse happen. It decreases. So CaCl becomes NaCl, that is 8:8 becomes 6:6. Here 6:6 becomes 8:8. Increasing pressure increases, but on temperature decreases. So this was all about structure of ionic crystal. In the next video, I will give you some questions, just a few questions. Then we'll shift over to imperfections and defects. So thank you for watching this video. I hope you would have been cleared about it. I have two parts of structure of ionic crystal of ZnS type and CaCl type, and here also CaCl type, and the last one AB2 and A2B type. So thank you.